Ladies and gentlemen, thank you very much for giving me voice. Today, I will be talking about biogas production, and due to recent article published in Applied Scientists by Austrian University under leadership of Professor Żeliński, with cooperation of Białystok University under leadership of Professor Joanna Kazimierowicz. The work is entitled Aquatic Macrophyte Biomass Periodically Harvested from Shipping Routes and Drainage Systems in Selected Region of Poland as a Substrate for Biogas Production. One of the identified obstacles of development of biogas plant is the limited sources of organic substrate. Hydrophytes, varying in morphology, chemical composition, and origin, prove to be viable alternatives. The Professor Żeliński decided to choose specific to their province, since they are multi-lake, thousand-lake district. And the trouble is like hydrophytes algas that needs to be utilized, otherwise to prevent the destruction of seawater, as was in order. They can be used was checking if these algae are suitable for being fed for anaerobic digestion and methane production. Methane fermentation is a well-known biological method for the conversion of organic substrates to biomethane. Its development is strongly hampered by most of all shortages of biomass, the use of which would be substantiated from both technological and economic perspectives. It should be emphasized that currently operating biogas plants are mainly utilizing highly loaded wastewater and sludge, as well as other biodegradable organic waste from the food industry and municipal sectors. Biogas plants utilizing plant biomass from dedicated energy works account for a relatively small share in this respect. It is therefore justified to search for a new source of biomass that can increase the supply of substrate used in fermentation processes. Research work conducted so far have indicated hydrophytes differing in morphology, chemical structure, and origin to be found alternative source of biomass in demand. A very important element, which in many cases determines the lost cost of effectiveness of using hydrophytes biomass for biogas production, is the cost harvesting of using hydrophyte biomass for biogas production is the method of its harvesting. There are multiple sources of biomass from macroalgae, macrophytobenthos, and aquatic vascular plants. These include closed systems for biomass proliferation, open systems, and hydrophyte-based wastewater treatment system. In addition, natural eutrophicated and degraded water reservoirs seem to be very prospective sources of hydrophyte biomass. Available reports on biogas production from aquatic vegetation harvested from natural aquifers are mainly used based on bench case studies or concept theoretical consideration. Viable climatic conditions have been measured and harmful limitation. Achievable amount of biomass can be made. Different in case of the vascular hydrophytes, whose biomass is obtained systematically during periodic maintenance and maintenance of hydrotechnical facilities. It was proven that separately that can be efficient source of hydrogen polymers, some force of this kind, but not checking if the plant of Mazur typical for Azuran lakes can be suitable also for these cases. The biomass of hydrophytes was harvested from sites located across Warmia Mazuri province of the Mazuria Lake district in Poland. The location was by motor hacking from Wisa River and shipping channel and mowing the Mazurian channel. Analyzing metal fermentation conducted under laboratory conditions using sequencing batch respirometric reactors. Experiments were divided into two stages that differed in the type of biomass tested, namely hydrophyte biomass harvested by mowing in stage 1 and biomass harvested by bottom hacking in stage 2. In each stage, experiments were performed in two variants that differed in the method of hydrophyte biomass preservation used before method fermentation, namely with fresh biomass used immediately after harvest from clean and tidy water reservoirs. With ensilaged hydrophyte biomass in other variants of biomass silage. There were two variants, biomass silage and fresh biomass, so what would be better for anaerobic digestion. This stage point of biomass indicated, and the process of method fermentation was chosen to be 6 weeks, and the liter of batch process were 5 decimeters, and the solid was 18% of raw material, 17% of silage, and volatile solid. The pH of the variant first was raw was 7.2, while silage was 6.2. The protein was 19% and 20% in case of silage, so higher proteins number. Lipids were 46, and there's another research used for experiments was as an equivalent experiment was sourced from anaerobic reactors operating in continuous modes, namely a mixture of macroalgae, chlorella accounted for 70%, sedimentus 30%. Fermentation was performed, the reactors completely mixed. Approach anaerobic was approximately 4 gram total solid per square liter. Organic load rate was kept 2 grams per decimeter, and the hydraulic retention time was 40 days. Before introducing anaerobic sludge, to the spirometric tanks. Its substrate feed was arrested for 10 days. The effectiveness of the anaerobic digestion of the tested hydrophyte biomass was determined with volumetric gas production method performed in sequencing batch spirometric reactors. Fermentation was performed at temperature 38 degrees. Bioreactors were equipped in a vertical stir operating at 100 rotors per minute for 30 seconds every 10 minutes. The active volume respirometers was 500 centimeters square. The initial organic load rate was 5 grams per square meter. To ensure anaerobic digestion inside the digester before the measurements, the contents were purged with pure nitrogen for 5 minutes as efficiency of 150 square meters per hour. Fermentation was continued for 40 days. Based on this composition was monitored chromatographically, and the measurement system was equipped in in situ absorption, in which 3 moles of sodium hydroxide was used to enable carbon dioxide fixation from biogas. A biometric production report was issued every 24 hours using software which generates results from the volume of normalized biogas. Endogenous biogas generated by the generic sludge was excluded from computations. Coefficient, the fit of model to lower was assumed lower, showed that values consistency coefficient did not exceed 0.2. The biomass energy balance achievable with the hydrophyte biomass harvested from the proper management of water courses, canals, drainage ditches, boats, and hydrotechnical drainage facilities was developed based on data derived from boat monitoring. Analysis of long-term records of wells related to periodic cleaning of water reservoirs was conducted in terms of the area and the average mass of harvested biomass. The contents of dry matter, as well as its organic and mineral compounds, were determined with the gravimetric method. The content of total carbonic organic carbon and nitrogen was assayed using Flash 2000 analyzer. Protein content was computed by multiplying nitrogen content by a conversion factor 6.25. Total phosphate content was determined calorimetrically in ammonium metavanadate and ammonium molybdate was to determine the content of reducing sugars. The contents lipids were determined with the success method. Methane from 9.70. Theoretically, thermal power, with calorie glass. The aquatic biomass harvested during the shoreline maintenance of water reservoirs, nation sites, and hydrotechnical installation is treated as waste not intended for economic use is disposed of. The literature is pressure. This state of affairs is influenced by the high content of organic nitrogen compounds in the biomass. The balance of reservoirs regardless the fresh substrate or substrate village. The hydration ratio used in produced was from coral reed was 64%, while the spirulina sedimentus was 90%. In the present studies, higher yields was achieved by fermenting the biomass hydrophytes than raw material. This could be side effects was reached methane producing was 51% in case while the raw was 59, so not very high difference, right? Methane was yield was 174 per gram of alga, while in case of raw material was just 77, so almost 3 times lower. So this shows that it's complete similar like contrary similarly to cabbage and almond, the butter is somehow fermented. But the case they don't measure how much fermented would be peak hour. So the suggested cause that silage of agar can be better than not raw materials and can be efficient source of fuel. This allows achieving the bagasse production achieving 866 kilowatts thermal per power, which would be with effect 84%, and this is the case what was unwanted, and the cleaning of water and resolving energy problem. So that's all what I wanted to say. Thank you very much for listening.